Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 51 in our incredible new tutorial series where you are learning artificial intelligence on the Jetson Nano. I will need you to pour yourself a nice big mug of iced coffee. I will need you to get out your Jetson Nano gear, and I will need you to get ready to learn some cool new stuff. What we're going to be doing today is we're going to be continuing in what we started last week, and that is to really begin looking at these deep neural networks and deep learning on the Jetson Nano. Hey, as always, I want to give a shout out to you guys who are helping me out over at Patreon. Your help and encouragement is what keeps this great material coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to be doing. Last week, we did our first program where we were really using deep neural networks or deep learning. And the way we did that was we configured our system to use the NVIDIA Jetson utilities and inference libraries to allow us to access some really sophisticated models for image recognition. And with those models, we could write simple programs that would allow us to use our webcam or a Raspberry Pi camera to begin to do some really cool image recognition. Now, if you remember though, there was a little bit of a glitch. Things worked great with the webcam, but if we were using the Raspberry Pi camera, depending on how we did it, we kind of had a trade-off between if we went the OpenCV route where we read the frame using OpenCV, then converted it to CUDA, and then did the image recognition, we got great frame rates, but the problem is we had like a 2-second latency. And for an OCD guy like me, latency is just something that I cannot tolerate. I cannot live in a world where there is a 2-second latency. We could do that, or if we use the Jetson utilities and created the camera under the framework of the Jetson utilities, it would load and it would do the image recognition and then do the display very quickly. But the problem there is there's an error in the way that they set up that GStreamer command down in their library. And if we set the frame size that we wanted, it doesn't make the frame that big. It takes the full frame from the camera and crops it, and that throws everything off. And then they don't really give us any handles to change it in our call to actually get the GStreamer, to get the GStreamer string that we really want. And so what we're going to do today is we're going to go in and fix that. Okay, we're going to fix that so you guys that are playing along at home with the webcam, you can just watch and be entertained. You guys that are playing along at home with the Raspberry Pi camera, we're going to fix it where you don't suffer moving forward in future lessons, that your camera is going to work right and work the way it was intended. So we are going to come over here, and I'm going to get out of your way. We're going to open up Visual Studio. We're going to create a fresh new program. I do believe I was working in the NVIDIA folder inside of PyPro. I am going to create a new Python file, and I am going to call it deep learning-3.py. Okay, fresh new program. Hey, I don't want to spend 30 minutes redeveloping the software that we developed last week, so we're going to run over to the most excellent www.toptechboy.com, and we are going to go to AI on the Jetson Nano lesson 50. That was last week's lesson. You can just search on that with this little green search icon. Search on that, come to lesson number 50, and let's come down here and let's grab this code that we had ended up with last week. So right mouse click copy, come over here, right mouse click paste, And if we take a quick look at it, just to remind ourselves, we were loading up the Jetson libraries and the OpenCV libraries. We were actually creating the camera using the Jetson utility GST camera, and again we passed it width and height, and then for the case of the Raspberry Pi camera you just pass it 0, telling it you want camera 0. Camera 0 is the first camera, camera 1 is the second one if you have the two board model. Nothing else we can pass it but those two things, so they've kind of tied our hands. I wish they'd let us pass a few more parameters in this create camera utility, but they didn't. And then we pretty much use the Jetson utilities to load the frame and then to find the object in the frame or identify the object in the frame, and then we convert that over to an OpenCV image and we do our display in OpenCV. If I'm going too fast, go back and watch last week's lesson. All right, so this is all looking good, but then if you remember when we run this, hopefully this won't take too long to run. Sometimes the first time you run them, it takes a little while to get everything figured out, and then subsequent times not so long. But I'm hoping this thing will pop right up. TensorRT is having to think about it a little while. Man, what did you guys do? Did you guys go in and try different networks besides, like here we're using GoogleNet? Did you try those other ones like the AlexNet and the GoogleNet 12 and some of those other ones? I had a lot of fun playing around with different libraries, and some of them are better at finding some things than other ones, and you can kind of play around with those and pick your favorite library. Boom! There we are. Okay, what do I like about this? Well, I like that it didn't crash. What do I also like? I like that we are running at a whopping 20 frames per second. I like that it sees my microphone and identifies my microphone, and I like that there is no latency. 1, 2, 3, 4, 5. There is no latency, and we are finding items. That's not lotion. What happened to pill bottle? Hairspray? It's not doing very well today. Okay, you see there's too much confusion around it, but you saw that it worked last week. Okay, does get the microphone. What is it that I don't like about this? Okay, we set our image to 1280 by 720, but instead of taking that and scaling it to 1280 by 720, it took the huge 3264 image and just cropped it. So really this is kind of a low resolution image because it didn't resize it, it cropped it. Okay, and we don't like that at all because it doesn't give us an ability, and plus the way this is done, you really don't have any choices in the size that you would want to make it, because if you just make up something, 1280 by 720 is about the only one that you can put in there, and anything else you put in there is going to cause it to crash, okay, because they didn't quite put the thought that they needed to when they did their GStreamer command. So we are going to live dangerously, and we're going to edit their library, and we're going to fix it. And we're probably going to break it, and we're probably going to regret the day that we ever tried to do something so bold. Okay, what I will need you to do is get out your GEdit. Okay, GEdit. So you come up here. I probably went kind of fast there. You click on the upper left icon, which is kind of the start button. You type in GEdit, and you get this little text editor here. I guess if I were braver, I would open it in Visual Studio, but I'm just going to do it in GEdit, which is a text editor. What you're going to do is you're going to say that you want to open, and where we're going to do is we're going to go to Downloads. Okay, we are going to go to Jetson Inference. That's where those libraries are. We're going to go to Utilities, and then we are going to go to Camera. Okay, and then what we are going to do is we are going to edit gst.cpp. Okay, gstcamera.cpp. So we're going to open that. All right. Now, because we don't want to mess this up and then be in some sort of hopeless, unbootable state, we're going to save a backup before we change anything. So I'm going to say File, and I am going to do Save As, and we'll save in the same place, but under CPP, I'm going to put Backup. Okay, like that. So I'm going to save it as backup so I have a fresh, unedited one. Okay, and then darn it, that gave me the GST backup now as the working one. So we'll come back over here, Open, and then mine is right here. I'm just going to go back to GST Camera CPP. Okay, so that was a lot of stuff really fast there. So let's pause for a second. Let's pause for a second, and let's make sure that you backed up GST camera.cpp. You backed it up as GST camera.cpp backup, and now you're back over here working on GST camera. In fact, I'm going to close this backup file. So the only thing that I have open is GST camera.cpp. The problem line in this massive library is about line 452. So come up here to Search, and then say Go to Line, and go to line 452, I do believe. Let me make sure that that looks right. Okay, I was a little bit off. Was that 428 was what it said? 428. Yeah, that's probably 428. It's a little bit closer. So the thing that we want is, do you see here on about line 428? And what this says is, I wonder if I can make this easier for you to see. Pardon me while I see if I got a bigger font. Preferences. Okay. Editor, font and colors. Let's make this about 18. Okay, that looks a lot better. All right, so if you look, this is where we are in the library launching the GStreamer command. And you can see that it's got several different cameras that it's looking at. It says if the camera source is in Vargas, that is not our oh, yes, it is. Okay. This one where it says if it's GST source NV camera, that is not our camera. Our camera is the GST source is in Vargas. And then you see that it's creating the GStreamer. It is creating the GStreamer string here. Okay, it is creating the GStreamer string here. And again, that is about line 428. It's where you could also search on else if, and then you could search on this GST underscore source underscore NVARGUS. Okay, then you begin to see here why I hate C. I hate C with a passion, because this is very, very hard to see what they're doing here. But what they are doing here is they are creating here the GStreamer string. Okay, this would be the string that, let's see, let me go to one of our earlier programs. Let me just go to like OpenCV, one of our very first programs that we ever did. And this was this camset command. So you see this in Vargas camera source. This is not good. I lost my spot. So let me do a tools search, go to line. Okay, there it is. All right, so that's good. So let me see if I can make these where you can see both of these things at the same time. I think I can. So what we are interested in is, this is the string that launches GStreamer. So you can see it starts with in Vargas camera source, in Vargas camera source. Well, we've just been not putting in the sensor ID, but they left in here an ability to put in the sensor ID, and so that's a string, and then what they feed in is they feed in the variable mSensorCI. Okay, and that part's fine. All right, but then what they do is they get this parameter video x raw memory NVMM. That's good, right? You see, that matches what we're doing. But then what they do is they set the camera width here at this first camera call. But if you remember, when we created this GStreamer string, you don't set the size there. You set that to full size, which is 3264 by 2464. And so this, rather than putting in the variable, this width needs to be 3264 and this height needs to be 2464. And then if you remember, we make the size right way out here. After this NVIDIA convert, we resize to the width and the height that we want. So you launch the camera full strength, and then you do the NVIDIA convert to convert it down to a smaller size. So I could put you through the torture of trying to edit this by hand. I could do that to you because that's what I had to do. But basically, I am going to give you a string, and the string will be down in the description below. And if it's not in the description, then look in the first link, because sometimes YouTube is strange and it won't let you put certain things in a description, but you can put it in a comment. But what you will find is you will find this all needs to be replaced. It's everything from this SS through this SS. All of this after this else if at about line 428 needs to be replaced. And I am going to replace it with this. Okay, and you can get this in the description, but I want you to see that I have one SS, I have a second SS, and then I end with the colon. But you can see what I did was, one thing I did was I didn't like my image that was coming off the Raspberry Pi camera because it was making me blue and washed out. And so I put in this parameter of white balance mode equal 3, which warms the thing up a little bit. And then we kept the sensor ID just like they did. But what we did was, you will see that rather than putting a variable in under width, we put it at 3264. At height, we put it at 2464. We had to change their frame rate from 30 to 21. Okay, like if you look over here, they had a frame rate of, where is that silly frame rate? They had a frame rate of 30. That has to be changed to 21. And then we do the flip method just like they do. And then we have the video raw X coming after the NVIDIA convert just like they did. But then we inserted those variable width and height here, which is a resize. So you start with the full image and then you resize it down. And then we basically have made their command here look like that nice GStreamer launch string that we have always used. But do not be alarmed. You're just going to get all of this. You are going to copy it. You are going to come over here, and you've got to make sure you want to replace that colon or that semicolon all the way to the SS. Don't select the curly bracket. Don't select the close parentheses. Right mouse click, paste. Okay, so now I have a new GStreamer launch command that will behave in the right way. So we are going to save GST camera CPP. We're going to save it. We are going to close this. Okay, and you're going to get that from the description at the bottom of the video. Okay, and so now I will close this up. Now what we need to do is we need to do a couple of quick bookkeeping things. So we've changed that file. Well, we've got to recompile it. All right, so we're going to have to go to CD, and we'll have to go to desktop, right, LS. Then we're going to CD where we are going to CD, nope, we want to go ... We're going to CD into downloads. We are going to LS, and now we are going to CD into Jetson Inference, like that. And then we're going to LS, and then we are going to CD into build. Okay, we are going to CD all the way into build. And then let me look here, give me just a second here. I got on the wrong page. You're going to have to give me a second because I want to make sure that I'm in the right spot here. I want to make sure that you get exactly what you need. Okay, I'm sorry for that little delay, but we are in the right folder. And in this folder, we are going to want to do a make. Okay, so we've got to make this again because we changed that 1C program. So it's like we got to put the whole thing together again, but this just takes just a second. The make is going very quickly. Okay, now we need to do a sudo make install like that. All right, now let's come back to our program. And what I anticipate when we run it this time, I'm not going to be filling the screen. It's going to be showing the background. Okay, it's going to be showing the background. So let's right mouse click, run Python file in terminal. I feel pretty confident that this is going to work. It's moving ahead, no errors so far. You guys leave me a comment down below. How many of you are working on the Raspberry Pi camera and how many of you are working on the webcam? I kind of think there's pros and cons of both. I like the Raspberry Pi camera better because it gives me more. Since you're launching from a GStreamer command, there's more parameters that I can set using the Raspberry Pi camera. Okay. Boom! Look at that. Okay, do you see how now you're seeing all the way from the wall way over here and it's recognizing microphone? Also, hopefully you see there's a little bit more natural color balance there. We are operating at 17 frames per second, and watch this. 1, 2, 3, 4, 5. No latency. You see that? Okay, no latency. Let's see if we can recognize something else. I always get distracted because I always want to see it do something. It thinks it's an oscilloscope, remote control, cellular iPod. Okay, that's pretty good. That's pretty close. iPod is about the closest it's going to get. Let's give it something good to recognize. You know what the problem is? This is kind of like what I told you. Recognition, really kind of wants a clear view, so there's too much in the screen for it to really do very good. It's got the microphone. Okay, that's good. Operating at 20 frames per second, no latency, and we fixed that problem. Okay, also come in and look. I'm going to quit out of this. Now you can actually resize this thing and it'll work. Okay, so now let's come in and let's say that instead of 1280, let's say I went 640 by, this would be what, 360? Okay, I'm going to resize it small. So you see, this is going to fix it. And with that other program or the library, the way they wrote it, you couldn't resize it because you had to set it to like one of three choices the camera gave you, and they didn't build in the ability to resize. So we're capturing the whole thing and then we're resizing it down. Okay, boom, there. Okay, you see what I mean? You see, I made it smaller and we're still operating at 21 frames per second. So now I can kind of make the window and the image any size I want. Okay, guys, I hope this hasn't been too tedious. I guess what we should talk about is we should talk about what if you mess things up. How do you get back to where you were if you mess things up? If you mess things up, what you would do is you would come back, open up your filing cabinet. You would come to desktop, documents. No, not documents. You would go to downloads. You would go, oh, sorry, I froze. How's that? Okay. From documents, you would go to, or from downloads, you would go to Jetson Inference. From Jetson Inference, you would go to utilities. And then from there, you would go to camera. And then remember how you made that backup? Okay, you backed up your GST camera, your GST camera.cpp. You created a backup. Well, what you would do is you would kill this one that you just edited. You would erase it. And then you would rename this one, the backup, back to GST camera.cpp. So now you have your original one back by doing a rename, and then you would come back and you would go to where we were. You would go to CD, downloads, and then Jetson Inference, and then build like that. And then you would do the make, and you would do the sudo make install again. And then that should take you all back to where you started, and then you could try again. But if you copy and paste from the message below, and you just make sure to put it at the right spot about line 428, it should work for you. Okay, this has been a little bit of a tedious lesson, but that thing bugged me so much that I didn't want to go through the rest of these lessons without being able to control the camera size or without being able to control the quality of the image. And so unfortunately, if I want to tweak the image, I'm going to have to go into that camera file, and I'm going to have to edit that GStreamer command. And you see where it is, and if you're a little bit more adept, you can play with it yourself, as far as tweaking the parameters to get the camera image that you want. If you're not adept at it, you can at least get something that works a lot better by copying the couple of lines of code that I put down below, and that should help you. Okay, guys, I hope you enjoyed this lesson. If you did, give us a thumbs up. Think about subscribing to the channel, and we will have an exciting new lesson for you next week. Paul McWhorter from TopTechPoy.com. I will talk to you guys later.